Hello peeps, today we are going to be learning about changing between radical form and exponential form. The reason we'd want to do this is because it's easier to simplify something that's in radical form, but if it's something that doesn't simplify, it's easier to read and write it if we leave it in exponential form if we're going through a long problem that we're going to have to be writing it over and over again. So each one serves its own purpose, and we need to be able to interchange between each of those. So the formula that we use for this, the rule that applies, is this formula right here in the center. X to the power of a divided by b is the same as the b root of x to the a power. So simply how this looks is if I have numbers where a and b are, I can quickly interchange between those. So if I start with something in the radical form where I have the cube root of 5x to the third, let's not do the third power, sorry, the second power. Okay. So I can change this to an exponential form that just looks nicer when I'm writing it on paper. So I have 5x, whatever's inside the root comes out, and we put that in parentheses every time. Always use parentheses on this. The exponent always stays the exponent. It's the top of our exponent. The only thing we're going to change is instead of putting this 3 here, we're going to bring it and put it in the bottom of the fraction in our exponent. Now, one way that somebody showed me to remember this is that this line acts as, in our radical, acts as the line in the fraction, and I've got 2 on the top, 3 is lower, so it's on the bottom. So this is your answer. You do not need to do anything extra. You just change it to exponent form and leave it just like this. All right, so another example is if I have the square root of 3x cubed, and this is all to the 5th power. So I take whatever's inside the square root, I put it in parentheses, 3x cubed. Okay, the 5 stays on the exponent, and I need a number to go here in the bottom. Because I have a root showing in my picture, it cannot be 1. If it was 1, it just wouldn't have a square root in the first place, and we wouldn't have any work that needs to be done. So remember that when we're doing square roots, we always do groups of 2. So since this is a group of 2, the 2 is going to go on the bottom here, and this is our answer. So if it's a square root and it does not have the 2 written, we know that that's groups of 2. So when I put it into exponent form, I need to put the 2 in the bottom of my answer. Now, what's really cool about this is what makes it so that squares and square roots are the opposite of each other. Because if I have the square root of 4, that is the same as having, and then I square that because I want to cancel it out, that is the same as having 4 to the 2nd power divided by 2. Well, 2 divided by 2 is just 1, so 4 to the 1st power, which is just 4. That's why when I need to get rid of a square root, when I'm solving an equation, I can just square it to cancel them out. All right, now on the other side, if I have a problem that is already in exponential form, I can take that and change it into radical form as well. All right, so if I have a problem like 6x that's in parentheses to the 3/4 power, I can change this to radical form, so it already looks like this. I can change it to a root by taking what's in the parentheses, putting that under the root. What is in the bottom goes in the bucket of my square root, and the 3 goes as my exponent. You can see it written in parentheses like I have it here, or as long as you're clear in your writing, you can just put the 3 as an exponent like this. Those are both accurate. So again, if I have 2x to the 3rd power, and that's all to the 1/2 power, I'm going to put that into a root. Whatever's in parentheses goes underneath the root. Whatever's in the bucket the bottom goes in the bucket. but because it's a 2, I can write it, but I don't have to write it. And then to the first power means I'm just going to have a 1 out here. Okay, this is the same as saying the square root of 2x to the third. I don't need to write the 1 and I don't need to write the 2 in the bucket because those are what we call invisible numbers. They're embedded into the symbol if they're not different, like the 4 and the 3 on the previous example. Okay. So that is all that we're doing today. So I want you to go ahead and try a couple of examples really quick. So I'm going to give you 2 different problems to do. We're going to have 5x, and then this is going to be a cube root to the 5th power. And then I want you to do 6x cubed, and this is to the 2/3 power. So go ahead, pause the video for just a moment. Everybody take a moment to write the answer to both of these and then come back and check your work. All right, so this one, I always add parentheses. So I have 5x in parentheses. The 5, this 5 right here stays in the top of the fraction, and the 3 goes in the bottom. Remember, the bucket goes to the bottom. This one is already in exponent form, so that tells me it needs to look like the other one, so I'm going to put it in radical form. The 3 goes in the bucket, the 6x cubed goes underneath the root, and then the 2 is going to come out here. This one you don't need parentheses as long as you're writing clearly so we can see the 2 is outside of the root. All right, the last thing we need to do today is we need to review how to simplify a radical. So a radical is these things that we had from last unit. So I have 3 square roots of 18. So this is not a cube root because the 3 is a regular 3. It's a big 3. It's not a tiny 3. So this is a square root. I'm doing groups of 2. So the first thing I do is I break down the 18. 6 and 3 multiply to 18, and 2 and 3 multiply to 6. I put my breakout buddies together. We can't have any snitches, so 1 dies. This 3 is going to come out with the other 3. So I have a 3 times a 3, square roots of 2, which is equal to 9 square roots of 2. Okay, if I have 6x cube roots of, let's go 24x to the 3rd power. So we break this down just like normal. We have 8 and 3, 2 and 4, 2 and 2. Remember, if you've broken it down like the 4 and the 8, we don't need those numbers anymore. This time, because of the little 3 right here, I'm doing groups of 3. And no snitches. So the 2 is going to break out of prison, and you can't forget about your variables. So the x's, there's 3 x's, they form a group, break out of prison, and no snitches. So now I have a 6, a 2, an x, and an x on the outside in the free world, and I have a 3 in the prison. We multiply all the numbers together, so I get 12x squared, square roots of 3. So that is how we do radicals. So you guys are ready for your assignment today. You need to do pages 8 and 9 in your packet. You need to do all of those. You need to do your 6.3 check on Canvas. And if you have not finished your 6.2 or 6.1 checks, go and finish those as well. And then if you run out of things to do, you can use that free time to quietly play on your phone, chat with a neighbor, or take a nap, but you should not be disrupting other people or leaving class early. So that is all for today, and I will see you guys back tomorrow.